Before we start the podcast, we wanted to let you know about WestOS. If you're a teacher or pupil at a school in Scotland, then you now have access to hundreds of quality assured video lessons created by teachers to support your remote learning. You should be able to find WestOS within the app library of Glow, where you can add the tile to your own personal launchpad. Click on the tile and you'll have immediate access to stream lessons in every area of the Scottish curriculum, with video lessons already available for biology at National 5, Higher and Advanced Higher. Now let's get on with the podcast. This podcast is sponsored by Lecky textbooks, revision guides and practice papers, everything you need to learn, review and prepare for your senior phase assessments. Browse the books at www.leckyscotland.co.uk and get 40% off using the discount code LeckyPodcast40. We're thrilled by the overwhelming support for our episodes featuring top-notch experts delving into various biological realms. Thanks to the feedback from higher biology students, we're launching shorter, punchy revision episodes. Get ready for quick summaries of key areas to turbocharge your exam prep. These short episodes can support your exam preparation and are not intended to replace other important aspects of your revision. In this short revision episode, we're going to explore how organisms maintain internal environments, tackle metabolic costs, and adapt to change. Quick, clear and exam focused to help you as part of your revision. The ability of an organism to maintain its metabolic rate is affected by external factors such as temperature, pH or salinity. Now salinity, we're talking about salt concentration. And in the Metabolism and Conformers and Regulators key area, we look at both conformers and regulators. Conformers, so for example reptiles and amphibians, their internal environment is dependent on the external environment. In other words, what's happening inside their body is dependent on what's happening outside. Now conformers have a low metabolic rate and can only live in a limited number of ecological niche, unless of course they can tolerate or resist variation in their external environment. Most conformers display behavioural responses to maintain optimum metabolic rates. And by that, a good example might be lizards basking in the sunshine to help raise their body temperature. When it comes to regulators, we're looking at mammals and birds. And regulators use their metabolism to control their internal environment. And that allows the regulator to be able to occupy a wider range of ecological niches. Regulators have high metabolic rates and require a lot of energy to maintain homeostasis. Homeostasis is the maintenance of their internal environment. Now, regulators maintain that internal environment regardless of what's happening externally. An example of homeostasis in regulators is thermal regulation, and that involves the maintenance of body temperature. Thermal regulation is brought about by negative feedback control. Now, within that, we need to look at the role of the hypothalamus within thermal regulation. Let's start with when body temperature increases. The hypothalamus detects this and sends nerve impulses to several effectors. Sweat glands ramp up their activity. More sweat means more heat lost as it evaporates from the skin. Now remember that we're constantly sweating, so the body responds by increasing sweat, not by starting to sweat. Arterioles leading to the skin undergo vasodilation, and that means that the blood vessels widen, allowing more warm blood to flow near the surface, and that allows heat to be lost through radiation, which is why you look red or flushed when you're hot. Now what happens when body temperature drops? Well, the skeletal muscles start to contract rapidly. That's shivering, and it generates heat. Hair erector muscles contract, causing the hairs to stand on end, and that traps a layer of insulating air close to the skin. Meanwhile, vasoconstriction occurs and the arterioles narrow, reducing blood flow to the skin and minimising heat loss. The hypothalamus is really like the body's thermostat. It's always working to keep internal conditions just right. So to summarise what we've looked at so far, regulators, which can also be known as endotherms, including birds and mammals, they regulate their body temperature at a relatively constant level using their metabolism. They've got high metabolic rates. While conformers, also known as ectotherms, including fish, amphibians and reptiles, they are unable to regulate their body temperature by physiological means. Their internal temperature is dependent on the external environment and they have low metabolic rates. It's important that organisms can regulate their temperature for optimal enzyme activity and high diffusion rates so that metabolism can be maintained. Remember that enzymes regulate metabolic pathways while oxygen, glucose and other essential respiratory substrates must be able to diffuse into cells, and temperature affects both of those. So hit subscribe on whatever platform you get your podcasts so you don't miss the rest of our short summary episodes nor our regular episodes with leading experts. And remember, this quick summary is intended as just one element of your broader revision plan. There are lots of resources available via Glow such as Scholar or WestOS, as well as BBC Bitesize. Or why not check out one of Lecky's great revision books and use the code LeckyPodcast40 to get 40% off on their website www.leckyscotland.co.uk.